Here we have two more examples on solving logarithmic equations. For example 1, notice I have a sum of logs. And what that means is I can use the property that says if the logs have the same base and I have a sum of logs, I can rewrite this sum as a single log and I can multiply the arguments. So I can multiply 50 times x over 2 and that'll equal 2. So let's simplify this multiplication. 50 times x is 50x divided by 2, which is 25x's, equal to 2. And now what else do? I'm stuck. So I say whenever you're stuck, change it to exponential. So we take the base of this log, we raise it to the second power, and we equal it to 25x. So this becomes 10 to the second power. Remember when there's nothing written as the base? That's a 10. 10 raised to the second power is equal to 25x. That means that 100 is equal to 25x. I divide by 25 both sides. X is equal to 4. And there's your answer. You can plug this in to here and you can check and see if your answer is correct. So let's do that really quickly, just so that you see that it is correct. I am going to check. So log of 50 plus log of 4 over 2, because we found that x is 4. I can rewrite this as a single log. So this would be log of 50 times 2, because 4 over 2 is 2. And this will be log of 100 is equal to 2. What is the log of 100? Well, since this is a base 10, this is asking you 10 raised to what power will equal 100? Well, 10 raised to the second power. So 2 is equal to 2. It checks out. That means that this answer is correct. Let's do the second example. For the second example, I have a difference of logs. I have logs that have the same base. The property says that if the logs have the same base and I have a difference, I can rewrite this as a single log. But instead of multiplying the arguments, I divide them. So there it is. I've rewritten this as a single log. And now I'm stuck again. So let's write this log as an exponential. That means the base, which is 10, I raise to the first power and I equal it to x over 8. That means that 10 is equal to x over 8. I want to isolate x, so I can cross multiply 8 with 10. That makes 80 is equal to x, or x is equal to 80. Again, I can check this result by plugging it in right here. So let's do that very quickly. Let's do the check. I'm going to write log of x, x is 80, minus log of 8 equal to 1. I'm going to use the property, the difference of logs property, which lets me write this as a quotient. That gives me log of 10 is equal to 1. And log of 10, how much is log of 10? This is asking you 10 raised to what power equals 10? Well, 10 raised to the first power equals 10. So 1 is equal to 1. This checks out, so this is correct. Now we're going to do one more example. This is example 3. And here we're going to have log of x squared minus 9 equals the log of 5x plus 5. Okay, now notice I have log, I have an equal sign. That means I can equal this argument to this argument. So very easily I can write x squared minus 9 is equal to 5x plus 5. Okay, now how do I solve this? Well, I'm going to make this equation equal 0 by subtracting 5x on this side and 5x on the other side. That gives me x squared minus 5x minus 9 equal 5. And now I am going to subtract 5 on each side, so that my equation is left equal to 0. So on one side of the equal sign, I have x squared minus 5x minus 14 equals 0. Notice that I end up with a quadratic equation. And anytime I see a quadratic equation, the first thing that comes to mind is factor. So let's use our method that we learned to factor. C is negative 14. B is negative 5. So I find two factors that I multiply together and give me 14. That will be 7 and 2. And I add them together and get me negative 5. So 7 has to be negative. That means that x squared minus 5x minus 14 I can factor as x minus 7 times x plus 2 equal to 0. I use the zero product property, so I make x minus 7 equals 0 and x plus 2 equals 0. That gives you x is equal to 7 and x is equal to negative 2. Notice you have two answers. Which of these two work? We have to check both to see which works. So both of these I'm going to plug in to the original equation and see which one works. When I plug in 7, here I'll get 7 squared, which is 49. And 49 minus 9 gives you log of 40. So I'm going to have log of 40. This is when x is 7. I'm going to have log of 40 equal to the log of, if I plug in 7 here, 5 times 7 is 35 plus 5, 40. So that checks out. Log of 40 is equal to log of 40. Now when x is equal to negative 2, let's see what happens. On this side, if x is negative 2, this will be negative 2 squared, which is positive 4. 4 minus 9 will give you log of negative 5. And right there, I can stop, because the argument in a log can never be a negative number. Okay? On the other side, just so that you can see, if I plug in negative 2 here, 5 times negative 2 is negative 10, and negative 10 plus 5 is negative 5. So you'll get log of negative 5 is equal to log of negative 5, but if you try to look for this value in your calculator, you will see that this is it gives you an error, okay? Because nothing, no number 10 raised to what power is equal to negative 5? That's what we're asking. There's no number in this world that you can raise 10 to and get a negative number. You will always get a positive number. So that means x equal to negative 2 does not work, and your solution is 7. I hope this video helps. I'll see you in class.